Dot. All right, so in your notes, week 7. God, can you believe it? Can you believe it's week 7? Well, okay, it's really week 6 for you, but it's week 7 in reality, which means we're only 2 weeks away from the halfway point of the semester. Oh my God. Is it going quickly for you too? Crazy. So, the world is an interesting place, but today I read something, health things, but this was kind of kind of funny. More people die from selfies than shark attacks. How does somebody die from a selfie?
Because if you're going like this,
Right.
and then
Like, right? So imagine right now somebody's trying to get a selfie with who? Who's like the coveted? Yeah, the Pope, right? Right? You run into the street and bam, you're dead. Okay? It really happens, right? But how frequent do shark attacks happen? Like, right? Yeah, it's like horribly small. So nothing to worry about.
and the shark is there, they don't even care.
Yeah. All right, so let's start with this. I want to just be clear because you have your first lab test due on Monday. Now, for the online students, they will be hearing this after. But how do you get to it? So you'll know, how do you get to it? Leslie already asked me today, so let's talk about how do you get to it? In my IT lab, I'm not going to show you, let's just say. Click on course materials, click on exams towards the bottom, click on office lab test, and then you'll find the first one listed. You download the stuff, you walk through all the stuff, you upload, and then it will grade you. Okay? All right. So the other thing is, does anybody remember me mentioning the last date to purchase my IT lab? October 3rd. So here's the deal. Most of you have already done it, but in case you haven't, please make sure you have a trial account. Because at least if you have a trial account, once they expire the ability to purchase, you can still convert it into a paid account. Okay? Clear? Okay, October what? 3rd. Okay. So, late points removed. I've had a couple of questions, and I had one of the online students supply to me a good example, so I'm going to cover it. So, in general, what this is if you miss an item, you can get the late points returned. And this is how you do it. You set up a Google Sheet, and she did this. Here it is. Okay? So let me increase it so you can see it. So here are the required fields that I have. Oh, by the way, anybody notice music still playing? Sorry. So this first one is the item that you completed that you're going to get the points back. The second one is the proof, which is a link to what? Yeah, show that you did it, right? Not that I don't trust you. It just makes it easier, okay? Used yes or no is a field I will input. My comments, that's pretty clear. There was one thing that she kind of pointed out to me. It's like, well, then how do you know what I want to use it on? Right? And I was like, oh yeah, that would be good, okay? So this is a field that I'm adding. Doesn't have to be in any particular order, but it kind of makes sense that this might be over here because you are the one that puts in this. So what you do is you create this sheet. It's called a spreadsheet, but in Google Docs it's called Sheets. You share it with me so that I can edit it, and then you tell me which items you want to make up. You give me this, and I'll give you the points back. I think this example hopefully clears that up for any lingering questions that you may have for that. But does that help at all, seeing it? Okay. All right, so, and the other question somebody asked me, they said, well, how long can I make up points? Have you wondered that? Yeah, till the end of the semester, right? Yeah.
And then I know there's like extra credit stuff for Code Academy.
So actually that falls in the, thank you. If you didn't hear it online, Angel was saying, there's the Code Academy stuff falls into the same category as the training for my IT labs. So if you complete those, then your link would be to those that you completed that would give you the points back. Was that going to be your question? I interrupted you.
I was gonna do my latest students and then combine with my Code Academy and that's full entire spreadsheet.
Yep.
And give it to you as one video.
Yep. Yeah, and you really don't even really have to give it to me until you want to use it. But I would, if I was a student, go ahead and set this up and keep track of it, because you'll forget, right? And if you forget, the cool thing is it's all out there and you can go back and find it. but it's just best to have it. Yeah. Does that answer it? Yeah. Okay, cool. So the hands-on, I've been thinking about this and I foreshadowed this. That's my new word. I've been sitting in a class with another instructor and he says that a lot. So my new class, my word is foreshadowing, right? So I foreshadowed that this was going to happen, but I had the dates wrong. So we are going to finish CSS and HTML in week 8, okay? And then we're going to take 2 weeks to do the movie. Okay, so here's what it's going to look like in week 9, and you can go ahead and start at least thinking about what you'd want to do. In week 9, what you will do is kind of plan out your movie. Like, here's some of the images, here's the topics, right? And then probably starting next week, I'll give lecture, at least part of a lecture on, you know, copyright, because you know I'm an expert in copyright, right? The students online are laughing because the students online, students in class are laughing because the students online don't know that I was limited to 15 minutes on YouTube until just last week, and I got repeated, and they're going, oh no, longer lectures. Yeah, that's true. Okay. So in week 9, I will start, before week 9, I will start talking about copyright. And by the way, you ever seen these videos where they remix stuff? You ever wonder how they get away with that? No, many of them are the original images. You can grab a little bit. You can't grab a lot. Okay, that's the key. And why I got dinged was I grabbed a whole video. Played it in class. YouTube caught it. And I knew better. That's what was crazy. Okay, so anyway, week 10, then I will teach you about how to use the YouTube editor because it's really great. You can use whatever program you want, but I will teach you how to use the YouTube editor, okay? All right, and then week 11 through 16, we're going to do JavaScript. So if you happen to be already kind of in the mode and enjoying Code Academy, we won't finish all of JavaScript, but I think we'll finish 5 of the first the first 5 lessons in that. Okay, so I'm just kind of giving you here's where we're going with this stuff. And if you didn't hear me say this, and if the onlines didn't hear me say this, is that I just started teaching this class full time. I was teaching one below it, and so I'm redoing all the material. So I'm really thinking about how this class is set up. So that's why I'm telling you. Okay. So that should be listed, by the way, under something like class topics. So those items in your notes, make sure you've put that under something like class topics. Okay. So now I want to talk about some of the lingering questions that came out of the whole binary discussion. So let me just see who remembers, right? Why binary? And why do we talk about binary in a computer class? Say it again? Yeah, and why is that? Okay, so yes, it is the language, and I say that in quotes, that the computer knows, but why is it the language the computer knows? Yeah, so the computer is run by electricity, and the only 2 states of electricity is on and off. So at its basic fundamental level, a computer only understands on and off. It's the level of complexity that we put in and that I'm about to at least hopefully give you a little more clue into, and Malin did as well, right? And here was the other, so why do we use binary? Because, what was the answer we just got? Computers run on electricity. By the way, if you're running your laptop and you're not plugged in, where's electricity? In the battery, right? So I know it may sound obvious, but at least, keep that in mind. And your phone, same thing. Your phone is binary. Any kind of, processing, device that takes input, processes, and creates output is a computer. So somebody asked me this, who created it? And I'm like, I had to actually Google it. So let me Google it for you, right? So I had to say binary, who created, right? And it's a guy back in look at this. I think this guy right here, right? This guy created it, but check this out. He created it in what year? 1679. Now, were computers created in 1679? No, he created this numbering system way back in there, but we didn't use it until we started building computers. And the reason, again, is because computers were built on electricity. Now, are the future computers going to be built on electricity? No, what do you think they're going to be built on? Alien power. No, it's solar power. Okay, so again, the binary system is on and off. You ever heard of quantum computers? Okay, so quantum computers are on, off, somewhere in between. And they're called qubits. Instead of bits, they're called qubits. So that's one place we may go because we are going to hit the wall. We are starting already to hit the wall of how many of these zeros and ones we can A, fit on a chip, and B, how many we can process at one time. Okay? So we are going to have to come up with something new. Because have you guys heard of Moore's Law? Have you heard of Moore's Law? Yeah, so Moore's Law is a law that was recognized back in the day because when we built computers, they kept doubling every 12 to 18 months. And what's happened is we've pretty much kept up with that. So Gordon Moore, the guy who helped create, I don't know, this little company called Intel, maybe you've heard of them. Sorry, it's kind of a joke, but true. Okay, that was observed and keeps happening, but we're going to hit a wall to where we can't keep doubling. Now, we could talk about whether we need to or not, but we all like what? We all like faster and smaller. Those are kind of the two things we all like to have. Okay, so here's the other question I got was, does anybody work with binary anymore? Typically not. Can you imagine? Imagine how challenging it is to do the coding that you're doing. Right? Just think about that for a minute. So imagine trying to code in binary. You're typing zeros and ones and a series of zeros and ones to try to make the computer do something. So no, really nobody works in binary. We call this layers of abstraction. So in your notes, it's called layers of abstraction. And this is a very common term in the computer field that we have, is that we go from binary to something like assembly or another level of system called hexadecimal, and then we keep going up the ladder to where we have something like what you're coding in, HTML and CSS. Ultimately though, that all, and I'll come to you next, Rachel, all gets brought down to zeros for the computer to understand it. Did you hear that? First, did you hear that? No? Because you were going to ask a question. You were like, already. Go ahead. Go ahead, though. Layers of abstraction. What that means is nobody really deals with the zeros and ones anymore. We deal with layers of abstraction above that. All the way up to the point of the level you're coding at. You're coding HTML, CSS, and you will be coding JavaScript, but ultimately all that has to come down to what? Zeros and ones. What converts your code to a 0 and 1, the code that you've written so far? Ultimately the browser combined with the operating system, right? Okay. Let's actually take a little deeper look. I created a folder. Oh, sorry. I did create a folder. Oh, by the way, this is a what? Flash drive. And if I just plug it in, what happens? Makes a noise. It actually, does it what? Does it sync?
No.
If I have it set up to sync, it would, right? There are ways that and by the way, I'm just going to drag that out real quick, right? And since this happened, and Joseph and I were up here, now that I'm done with it, because I dragged it, right? I moved it from the USB, I dragged it out to my desktop. What should I do with the USB now? And what does that mean? You come down here. Okay, and I did this. Wrong or right? Why? So the worst time you do that is when it's writing to it. Okay? And it is good to do the whole safe thing, but how many of you do that? Just pop it out, right? Okay, then don't come whining to me, nor will I come whining to you when this thing goes out, okay? Because it will probably happen. I don't use this as a backup. Okay, so let's look at this. So I've created some different files here for us to talk about binary. And the first one, and this one is real. By the way, what little program is this that I'm using here? Notepad. Woohoo, Notepad, really sophisticated, right? How many characters on the screen? One. How many zeros and ones could you speculate that takes to represent in the computer? 8. 8 bits, 1 byte. And by the way, notice how and I know it might be a little hard for you to all to see in the back, but it says 1 what? You remember Maitland talking about slack space? Yeah, so the computer will reserve a certain amount of space, but this actually is not even what he was talking about. If I right click and I do properties, right, it's actually 1 byte, which equals 8 bits, okay? But really, okay, so that's true. So that one character, right, when we're looking at it here, has been converted from binary to our understanding of that through what system? Anybody remember? No, good. Through ASCII. And he talked about that where he showed the chart, right? So that's why, because ASCII has, for every character, or and also special characters, there's 8 bits, 1 byte. So if we put 2 characters in there, how many bytes would it need? 2 bytes. 16 bits. Now, there is something, by the way, that ASCII system works great for our characters, our US characters. Who does it not work so great for? Anybody else? Okay. So when they created this was very much centered because the United States created it on our language, but these days, do we have to move beyond that? Computers work all over the world. How do they understand everyone else's language? And the answer is in the next file that I have here. And it's called Unicode. So in your notes, Unicode is actually the follow-up that we had to create to represent all languages. Now, you can see it on the screen again, but how many, or not again, but how many bytes does, and by the way, this is still an A. But in this case, how much room did it take? Let's go look at it. It actually showed on the screen. Takes 4 bytes, which is how many bits? 32. So that means in Unicode, we need 32 of those zeros and ones to represent each character so we can represent more characters. Oh, you got it? But again, it takes up a lot more zeros and ones. But ultimately, this is still minor compared to how many I have access to, right? I mean, think about how many I have on this puppy. How many? Sorry, I should know. 4 gigs. How many zeros and ones can I fit on 4 gigs? Okay, a lot is good. I'll take that. It's a large number, okay? All right, so we move from ASCII, and by the way, this is called, and I actually will tell you I talked about this in your notes, so let's go ahead and get this term, right? Why learn it? We're talking about binary. Oh, we'll talk about that in a minute. Well, really what we're talking about is coding schemes. So this ASCII and this Unicode are coding schemes, but really the other way we could talk about this is file types, right? So the file type itself. So let's look at a few more, because I think it's actually worth kind of at least delving into this a little more, okay? So now, what kind of file is that, if you can see it? HTML. Now, if we look at, and by the way, you can already tell, right, how big that file is. And again, it's only 1 character. How big is it? 1. So what would you speculate about how the file format for HTML files? It's okay, it's actually not in this case Unicode. It should be. Actually, Sarah is absolutely right. It should be, because imagine all web pages ultimately have to be read by all the different languages, right? So in this case, what I realized after I created the file is I made a mistake. So I went ahead and I said, and by the way, now if I wanted to open an HTML file, anybody ever done this particular, and show just a screen so they can see it? You ever tried to figure out how to open a file? So in this example, what program by default will it open when I try to open this file? Internet Explorer, my least favorite browser. You all know that, right? Okay. So in this case, if I wanted to open it as a web page, I would use that. But if I wanted to open it to edit it, I would open it with something else. And maybe in this maybe something like Notepad. And actually, in this case, I probably wouldn't choose TextPad, although I could, right? So tell me, and you should know, is this really an HTML file? What is it missing? What? Yeah, it's missing what? Yeah, it's missing all the tags, right? So I was kind of trying to fool you a little bit. But ultimately, it will be saved in this same Unicode format, okay? So web pages are saved in Unicode, all right? Now, what file is this? What kind of format is this? Microsoft Word document. Again, it's only 1 character. Now, you can already see before I show you the details, how much bigger is this file? Yeah, huge, right? File, properties. Again, one letter. How many? 11. How do we say the KB, kilobits, which really means for each kilo it's 1,000. So for 11, it's 11,000. Yeah. Well, 11,000. Well, actually, it's, actually, now we get to talk about what I'm going to foreshadow in a minute, the difference between big B's and little b's. Big B's are bytes, little b's are bits. Okay? But we can say it's much larger than a what kind of file? An ASCII or a Unicode file, right? For the same character. Why do you think that is? Why are Word documents formatting? Formatting. Word throws on top of the characters itself a huge amount of formatting.
Because it has different types, like Arial and the
Yeah. There's so much. There's so much we couldn't even get into. You don't even care about. But the answer is it just takes a lot more. Okay? So we've talked about text files. We've talked. Oh, and let's look. What kind of file is this? Yeah. Now, actually, is a PDF an image? Let's first in our notes. What is a PDF file? What does it stand for? You all have heard of it. But what does it mean? Portable document format. Now, you can tell by just looking at this screen, and go ahead and pull the screen down now, how big is this? Again, one character. Is it bigger than a Word file? Yes. Hugely bigger than a Word file. Why is a PDF so big? So very good. So it is basically that you can open it up on any system. You still have to have a plugin to open a PDF. But here's what it does, is it basically prints that file and all the print characters go into the output file. Okay? By the way, do you know how to create a PDF document? How many of you don't know how? Let's show hands. Can we show hands? How many do not know how to create a PDF document? Oh, you're going to be so happy. File, save as. Where's it at? Let's just.
This was in my IT lab. Oh.
Did you see it?
Yeah.
All you have to do is save it as a PDF. Okay? So all you're doing is saving it as another type of file. But in this case, it's another type of file that requires what? A lot of zeros and ones, right? But ultimately, going back here, ultimately, that's just a different kind of file with a lot more information stored so that it needs a lot more zeros and ones to tell it how to represent that file. Okay, we're almost done with looking at the files, but I at least want to have this conversation. How about these two types right here? Have you seen these two types of files? JPEGs. And by the way, let me just do this. Let me open one up. Oh, there's nothing in there. Looks like it, right? 1 pixel. Typically, how many pixels in a standard photo these days? Could be 1080, which means 1,800 across by, could be 1,900 down. This is 1 pixel, right? So it's kind of the equivalent of one character, except it's a graphic. So to represent it, would we use the ASCII system? No, doesn't do graphics. Would we do Word? Doesn't really do graphics, although we could put graphics in there. So this is where we start talking about file formats for images. So let's look at this. How big is 1 pixel? 68. That's small, right? Again, 1 pixel. So really we're just talking about a file type, another kind of file that takes up less space. Now, JPEG. Before I even show you, well, okay, I already did, but if you were watching, speculate whether JPEG would need more or less space. It's the same pixel, it's just 1 pixel. More. And why would it need more? Because typically, what kind of files are JPEG files? By the way, the other one was how many? 68 bytes. This is 641 bytes. So in this case, when it's a pixel in JPEG, it's going to try to represent it as a photograph. So photographs have a lot more detail. Okay? So we have to have a coding scheme or a file type that represents those. Any photographers in the room? Any photographers? What's the highest quality photo you can create these days? A raw file. A raw file is of when you use a camera to shoot something that grabs all the detail from the lens. Most of the time, you all are dealing with JPEGs, which is a compressed file. Okay? All right. So now these are graphics, the two. So with the one that takes less space is which file? The PNGs. Okay?
Isn't PNG like better detailed?
No. Not necessarily. It really depends. Very good. Actually, it depends on what you're trying to represent. When we're doing web pages, we will figure out based on what I'm trying to represent. Because if I can get away with a PNG, I will do it because it will take less space. But if I want a high quality image, then I just try to decrease a JPEG because I still want that nice, beautiful photo. Because how many websites have nice, beautiful photos these days? Right? I mean, you could just sit and look at nice, beautiful photos all day, right? Okay, so what kind of file is this? And what kind of file? So it's Windows Media, audio and video. So how do we create, through a coding scheme, an audio-video file? Here's the answer, okay? How many have heard of frames per second? Okay, so if a video is 60 frames per second, each frame is basically an image. So imagine 60 frames per second. That's 60 images plus an audio track. How big are these files going to become? Huge. By the way, I tried to record just 61. I tried to record 1 second, but my recorder wouldn't let me grab it, so I had to get 51 seconds. But this is actually not as big as I would have thought. Look at it. It's 68, how many? 61 kilobytes. Oh, actually, is it bytes or bits? Because actually this is kind of our next discussion. The big B is bytes, bits, my bad. Oh, see, I did it wrong again. Big B is bytes, little b is bits. Okay. Yeah, so in this case, I was just pulling it off of my webcam. And actually, that's a really good point, because what he's asking right here, look at this. If you can see it, yeah, show the screen here. The frame is 650, right? So that's a fairly small video, 650, right? And again, it wasn't even 1 minute, right? It was 51 seconds. But still, right? I mean, it's still fairly good size, but the quality was nothing, okay? And by the way, anybody know what this kind of file is? Yeah, this is an audio file. And would you have expected it to take more or less than the video file? Less, because this case, right, again, it's just audio, right? So again, everything has to come down to a coding scheme, which is really you can think of as a file type. Did that, huh? Yeah, it's not totally CD audio, which by the way, is CD, the native format on a CD, is it high quality? Yeah. What did we do years ago to it to make it more web friendly? We compress it into an MP3, then created what famous company? Napster. And what happened to Napster? Why did Napster go down? No, the answer to why Napster went down is because we could take them down. Because Napster had a centralized server. What happened the day after? By the way, what we did is we just took the server down. And not when I mean me. The collective we means the United States federal system, right? Because there was a lawsuit. What happened the day after Napster server was taken down? 10 more showed up that figured out how not to have centralized servers that led to what that we have today. Peer-to-peer, file sharing, torrent. Stuff we'll talk about. How many of you know that, okay, no, don't show them. How many of you know the term dark web? Okay, I have a video I want you to watch on the dark web. Okay, so we're going to talk about the dark web. All right, so ultimately, and I said this last week, everything has to be converted into binary for your computer to use it. We just showed some examples of file types today. Okay? So the other thing I wanted to say was about the two Bs. So let me do this. If you wanted to, well, and actually let's just say this. Let me go back here. Sorry. So this first one, the big B, so big B represents bytes. So 8 bits make up 1 byte. And then the B, little b represents bits, right? So the reason you want to know this is when you're looking at computer ads, how do we talk about memory in computer ads? Do we talk about them in big Bs or little b's? Big Bs, megabytes, gigabytes. When do we talk about things in little b's? Internet speed. So this week, I want you all to go and do an internet speed test. Okay? And I'm going to show you one right now. Let's see. Let's see if the school, the other day when I did this in class, it was smoking. Okay? And I mean in a good way. Okay? In this room. Because what kind of connection do we have as a campus out to the internet? Yeah, multiple T's, when really T's are an indication of how much pipe you have. Okay? Look at this. Wow, 442 what? How? And it's going to show you in a minute, but notice this right in the center. What is it saying? Bits per second. Okay? So in your notes, the difference, what we generally use the little b's for is communication speeds. Okay? So our first number is now our down and downloads. By the way, which is more commonly used by you when you're browsing the internet? Uploading or downloading? Downloading, and we'll talk more about that process. 439 megabits per second. I challenge anybody to have that speed. I don't have that speed at home. I would be so happy to have that speed at home. That is ridiculously fast. Huh? Yeah. So the ping right here, and ping basically says send out 1 bit, see how long it takes to get back, right? Now let me say this, right? This is very high. It's not that I want you all to be jealous or jelly or anything like that, right? So, but what in this screen would you not share? Yeah, right here. Why would you not share your IP from your home connection? Okay, so what I'm hearing in the room, if the online students, and bring it back, if you're not hearing this, right? So bring it back to me for a second. So if you're not hearing this, this IP is a little bit of an exposure to you. And what this means is anybody that would know your IP can't necessarily get into everything that you have, but if they have some knowledge, they can try, okay? And this also depends on how much your router is locked down. How many know what I mean by these terms? Okay. Huh? They can try to act like they're you, okay? But ultimately, you just don't want to share this a lot publicly, right? So here's what you would do. Let me just show you so we can. So you take a print screen. So just include the top, right? And then upload it and put it in your Google Doc. So for next week. But in general, we'll be talking about network here in the next couple weeks because it's really important for you to understand how to make your home more secure. Okay, this is just a necessary of our life these days, okay? So the 2 things you need to include for your kind of, let's make sure you get these concepts are the form results, which I'm going to show you in a minute, and the internet speed test. Now the internet speed test is important also for those of you paying more for your internet speed. How many of you know if you're paying more for a higher speed? If you're paying more for a higher speed, you should be checking that number more often. Because like for me, Comcast and I have this wonderful relationship where I try not to call them. Because when I do call them, we complain really badly. And I always say, I'm quitting you. Did I tell you this story? I call up Comcast every year. I'm quitting you guys, man. You're horrible. And they're like, but Miss Waller, we really have a special deal for you. I'm like, well, let's hear it. Right? Every year I do this. Every year I do this. And this year they gave me some additional speed, which was nice. Right? Yeah, so this is good to do. All right, but here's the other thing. So you need to include the internet speed, print screen. And here's what I want to show you is on your form, you go to responses and you do summary responses. Okay, so you can actually just give a link to this if you want. But I want to show you, interesting, right? So we talked a little about this, and now we have how many people filled out my form? Joseph has more than me, and I have all of you. How many did you get? 75. That's wonderful. Put it up on Facebook, right? Okay, so, but in this case, right, again, I'm almost 75, over 75% of you are using Windows, 20% Mac, some of you are using Chrome OS. Windows, 41% are using Windows 10. Still on Windows 8, Windows 7. Windows XP still alive, right? Two people's using it. You know, 93, 94% of you have a smartphone, right? And all of that percentage, almost 60% are using Android. Okay? Yay! Sorry, no, I shouldn't have a horse in this race, but I guess I do a little bit. And by the way, this number right here, are you passing this class? This indicates almost 90%. Do you think that reflects reality? Yes. Why do you think this doesn't reflect reality? Because of the people that have done this, they're probably the students that are focused on this class. It's the students that aren't focused on this class that haven't filled this form out, because really the number's around 70. I would love it to be 80. I mean, if this was true, oh, happy dance for me, okay? But this is just not true. But it could be true. You could all help make this true, okay? All right. So for next week, what are the 2 things you need to provide to me in addition to the notes? Form results, and again, you can just give me the link to yours, or you can take a print screen, right? But print screen might be kind of hard unless your resolution's really high, but that's fine too. And what else? What else do you have to provide to me? Yeah, internet speed. And what do you want to not include in that? Very nice. Let's show them. Let's say goodbye. Bye, guys.